So far we have imported and cleaned the dataset, and we have added some more features. Now, before we are going to create a machine learning model, we should deeply understand the data and identify the one or the other relationship between features and the label house prices. And that's exactly what we will do in this and the next lecture. We try to identify factors or features that influence house prices. And there's no better way to do this than by creating informative graphs. So we have still saved the data frame df. And first of all, again, we want to inspect the median house values or prices. So that's the label or the values that we want to predict. And we create a histogram with 100 bins. And again, we can see that house prices are kept at 500,000. Now, in a very first step, we could try to identify linear relationships between house prices and the features. And we can actually create a correlation matrix with the method core. And here we get the correlation coefficients between pairs of features. So for instance, the correlation between longitude and latitude, minus 0.92. And actually we are only interested in correlations between a label and features. So between house values and the features. So these are the correlation coefficients, and we can also sort them from high to low. And actually a correlation coefficient is between -1 and 1. And -1 means that there's a strong negative correlation or linear relationship between both random variables. And a correlation coefficient of 1 means that there's a strong positive linear relation. And finally, a correlation coefficient of around about 0 means that there's no linear relationship at all. And actually, it's no surprise that we have a perfect positive correlation between house value and house value. Then next, it's getting more interesting. So we have a clearly positive relationship between median income and median house value. So the higher the income, the more people can pay for the house. So this is a no-brainer. Then next, also, we have a positive relationship between rooms per household and house prices. And actually, the rationale behind this could be that the larger the house, the higher the price. Then we have two features indicating the size of the district, total rooms and total number of households. And there seems to be a positive relationship with the median house value. And one could argue that the larger districts have a better infrastructure, so in terms of shopping and so on. And this could definitely influence house prices. And also we have a positive relationship between the age and the value. Next, there's only a weak or no relation between house price and households, total bedrooms, population per household, and population and longitude. And this doesn't mean that there's no relationship at all, but at least there seems to be no linear relationship. Next, we have a negative relationship between latitude and house prices. So we will further analyze this in the next minutes. And finally, we have a strong negative relationship between bedrooms per room and the house value. So the lower the bedrooms per room, the higher the house prices. And this means that the more non-bedrooms we have in a house, the higher the price. And this is pretty intuitive, because additional non-bedrooms like hobby rooms, TV rooms, or whatever are not essential for living and is more expensive as the houses must be larger. So to sum up, the feature median income might be the most important feature. And again, we can also analyze here the median income feature with a histogram. And again, we can see that this feature is already scaled and we have values between 1 and 15. And actually the most frequent values are around about between 2 and 4. And we have actually a cap at 15. Next, let's create a scatter plot between median income and the median house values. And we actually create a regression plot with a linear regression line. So we can do this with a Seaborn joint plot. And here on the x-axis, we have the median income, and on the y-axis, the median house value. And again, we can see the histograms here for the house value and here for the income. And here we have actually the data points. So this is a scatter plot with a linear regression line. And we can see clearly that the median house values are capped at 500,000. And we can also see that there is a strong positive linear relationship between house values and the income. So the higher the income, the higher the house prices, and this is of course no surprise. And actually, instead of creating a scatter plot with a regression line, we can also create a so-called kernel density estimator, KDE. And again, we have median income on the x-axis and median house value on the y-axis. And we can see here the most frequent values where we can find most of the data points. So the most common combination is an income of 2 and house values round about 100,000. And also here we can see a positive linear relationship. Next, we can create a scatter plot with the plot method. And on the x-axis, we want to have the longitude, and on the y-axis, the latitude. And actually, we can also determine the size of the data points. And actually, the size should be determined by the population. So the higher the population in a district, the larger the data point. And we give the label population, we define the fixed size. And finally, we can also define a color for the data points depending on the median house value. And we select the color map cool warm. And we pass true to the color bar parameter to create a color bar. So let's simply have a look at the graph here. And also we create the Y label and X labels, latitude and longitude. So each and every data point here is one district, and on the x-axis we have the longitude, and on the y-axis the latitude. And the larger the data point, the higher the population. And dark red indicates house prices of round about 500,000, and dark blue indicates the prices of round about 100,000. Now, if we have a closer look at our graph here, then this looks like the shape of California. And it would be helpful to have somehow also California here included, so the map. And we can actually do this. And first of all, we import matplotlib.image as mp-image. And actually in our folder, we have the image file california.png. And we can pass this to mpimg.imread. So let's simply run the cell. And let's have a look here inside. So mpimg.imread actually reads the image from a file into an array. So each and every image can be represented by a matrix with numbers. I don't want to go into detail here, but let's have a look here at the matrix array. And now we can also display the image by passing the array here to plt.imshow. And it says here that with plt.imshow we can display an image. So let's have a look here. And we can define the figure size. And finally we have to code also plt.show to display the image. And this looks like California. And unfortunately we do not have the longitude or latitude here on the axis. But we can add this. So we can change here the axis labels, and we can define new axis labels. And actually we can do this with extend. So let's simply have a look here. And now we have here the coordinates for California on the x and y axis. So of course we have to know, or we have to search for the coordinates before, but we have done this already. And actually there are better ways to create geographical plotting, but this is a hands-on approach here and it works. And now in the last step, we can actually combine here the California map with our dots here, with our data points. And that's exactly what we are doing now. So first of all, we're creating the data points, and then we create the map. And here we can clearly see that the more expensive houses and the more expensive districts are near the ocean. So I think this is Los Angeles and this is San Francisco. And actually in the inland, the houses are getting more affordable with prices around about 100,000. So now let's go on. And actually we also have the categorical feature ocean proximity, and let's get the unique values. So we have 5 different categories: nearby, less than 1 hour to the ocean, inland, near the ocean, and island. And now we can filter for the categories, and for each and every category we can create this graph here. So for instance, at index position 3 we have near the ocean. So let's create the data frame dflog for location. So it's the near ocean location. And again, let's create the plot here only for the near ocean districts. And here we can clearly see the near ocean districts. In the most cases, we have here dark red, which indicates high house prices. And the same we can do for the inland. And clearly prices for houses in the inland are lower. So that's no surprise. And we could conclude that location matters. So finally, let's go back to the full graph. And actually, before we analyze the linear relationships between house values and, for instance, latitude and longitude, and if you have a look here, so we can see that there shouldn't be a linear relationship. So let's concentrate on latitude. And here we are starting with high house prices. Then next we have low house prices, then again high house prices, and again low house prices. So there should be a relationship between latitude and prices, but no linear relationship. And the same holds for longitude and house prices. So we are starting here on the left-hand side with low prices. Then here we have high prices, then again low prices. And here we have high prices, and finally we have again low prices. So again, there's no clear linear relationship between latitude, longitude, and house prices. But nevertheless, location matters. And actually with a non-linear machine learning model like the random forest regressor, we should be able to capture the relationship between location and house prices. Alright, thanks for watching, and see you also in the second part. Bye.